So we're going to look at one of the new formulas that we have then. So area of a triangle. So obviously we found area of a triangle before. You would have found area of the triangle from first year using your kind of usual formula, which is half base by height. So what we're looking at now is using coordinate geometry and using a formula in that to find the area of a triangle. And in coordinate geometry, we do have a formula, and that formula is for finding the area of a triangle which has a vertex 0, 0. So that means that the triangle has to have one of its corners at the origin. Okay, and when it does, then we can find the area of the triangle in this way. So half by the modulus or absolute value of x1, y2 minus x2, y1. And that modulus just makes sure that the area is going to be positive because we obviously can't have a negative value for area. And as noted there, yeah, it includes modulus notation. So if we're finding the area of this triangle here, we'll just put down our formula. Said before, it's just good practice to write down the formula for ourselves. Then we can sub in our points. So one, let me see, I'm going to just color code these a bit so we can keep it clear. So this is x1, y1, make this x2, y2. So here I'm going to have 1 by 6 minus x2, which is 7, by y1, which is 4. Okay, so 6 minus 28, which is a half, minus 22, which is a half by 22, which is 11 units squared. Okay, so we don't actually know what our units are here, so we'll just say units squared. Okay, so you can see how subbing it into our formula there, fairly straightforward, just making sure, I suppose, that you line up your points correctly, so the x1, y2, x2, y1, and then making sure that you're subbing them in just correctly with that as well. So if the triangle does not have 0, 0 as a vertex, and this is probably what you're mostly going to come across is ones that don't have 0, 0 as a vertex, then what we have to do is we translate, so that means to move. So we're going to move one of the points to 0, 0, and then we're going to do the same thing with all the other points. And what that means is we're taking a triangle that we have in one section of our coordinate plane, and we are just moving the triangle and finding essentially another triangle that would have a point 0, 0 that would have the same area, that would be the same shape, and then it lets us use that formula. So it's going to be then, as I've said there, we're going to use the translated points in the formula then. So if we're given this one here, 5, 2, 6, 7, and 2, 9. So we have to pick one of the points, we're going to translate it, and then we're going to do the same thing to the other points. So if we were to pick 5, 2, so I want to get 5, 2, and I want to move it to 0, 0. Okay, so I want to move it to the origin, I want to move it to the point 0, 0. So what that means is that for the x coordinate, I would have to take away 5, and then for the y coordinate, I would have to take away 2. Okay, and that will get it to 0, 0. What we're going to do then is we're going to apply the same thing to the other points. So if I take away 5 from the x coordinate, that's going to leave me with 1. If I take away 2 from the y coordinate, that will leave me with 5. Okay, so the same translation. Same thing goes for 2, 9 then. If I move that one the same way, so taking away 5, so 2 minus 5 gives me minus 3, 7. So these are my new points, okay, and these are the points I'm going to use now in my formula, okay, rather than the ones that I had originally. So again, writing out my formula, x1, y2 minus x2, y1, okay, and let's sub them in, so we'll go 1, 7, minus 3, 5. Okay, and continuing on, I get 7 minus, and then this is minus 15, which gives me 7 plus 15, which is a half of C22, which is same again, half of 22, which is 11 units squared. So the key thing there, moving the point and then moving one point and then applying the same translation in the same way to the other points. So we did the same thing. We took away 5 from each of the x coordinates. We took away 2 from each of the y coordinates. So 5 from the x, 2 from the y, and then just use those points in our formula then, in our question. So looking then at kind of some other ways that they could ask this. So here we're looking for a vertex and given the area of the triangle. So the area is 13 square units, where A is given, B is given, and C is this. Find the possible values of x. So what we notice here as well is that none of the points are at the origin. None of the points are 0, 0. So that's going to be the first thing we have to take care of. So let's work with A. Okay, so A is 3 minus 1. And for that to go to 0, 0, well, I would have to take away 3 from the x coordinate. But this time I'm going to have to add on 1 to the y coordinate. So let's do the same thing with B. So 5, 3, and you'll notice that we're trying to keep, we want to keep C in the question as well, because that's, we want to work with that point, because we need to work out what x is. So that will give me 2, 4, because what some people might be inclined to do is say, well, I'll move C to the origin, and I'll just take away x. And you can do that, and you'll end up with minus x then in some of the other points. It just makes it a bit more confusing. It's easier just to focus on moving one of the ones with numbers and get rid of that altogether. So moving this one in the same way, that will give me x minus 3 and 5. Okay, so that's what I'm going to use in my formula. So a half times, let's see, now we've written this formula down a few times, so you'll forgive me if I don't write it in again. So 2 by 5 minus x minus 3, excuse me, 4. Okay, let's keep going. So a half by, let's go 10, and then it's going to be minus 4 by x minus 3. So a half 10 minus 4x plus 12, which is a half by, getting 22 again, minus 4x. Okay, how much space do I have? I have space down here. So we're going to take this one then. So we know that this is my area, and we know that the answer is 13. So tidying that up then, if we get rid of the half in front, multiplying by 2, I get 26. So I have that, the modulus, make sure, remember this is that modulus or absolute value. So the modulus or absolute value of 22 minus 4x is equal to 26. Now at this point we have two different ways of doing this. Okay, so we have two ways of doing it. The first way is to say, well, if that part, this middle bit here, inside my modulus, if this part is equal to 26 when I take the absolute value of it, when I take the positive value, well then that either means that 22 minus 4x is equal to 26, or 22 minus 4x is equal to minus 26, because if it was minus 26 and I took the absolute value, then it would become positive 26 again. So continuing on, then 22 minus 26 is equal to 4x. So we're getting the 4x over this way and the 26 over the other way. So I get the minus 4 is equal to 4x, and I get that x is equal to minus 1. Or here, then doing kind of something similar again. So minus 4x is equal to minus 48. So x is equal to 12. Okay, x is equal to 12. So again, I suppose coming up with two answers, which is what we expect. Now the other way that we could take this question then is to square both sides. So 22 minus 4x squared is equal to 26 squared. Okay, and we are ending up then with a quadratic that we have to work with. And sometimes I suppose people don't necessarily like working with the quadratics. That can be the annoying part for some people. Particularly with one like this where we're getting quite big numbers. We're just going to go with it and see what happens. We should be able to end up with the same answer. So if I take it up here, so 16x squared minus 176x, and let's bring that over. 484 minus 676 minus 192. Okay, we're going to see now, is there anything that we can divide across by to make this an easier calculation for ourselves? And there is. We can divide across by 16. We get 11x minus 12 equals 0. That gives me x minus 12, x plus 1. And I get that x is equal to 12 and x is equal to minus 1. That's my two answers. Okay, and expected, because that's the two answers that we had here as well. So either of those methods will work. You obviously don't have to do both of them. And it really comes down, at that point, it just comes down to your absolute value and how you kind of engage with that and what the the obvious one for you there is. So we're going to look then, we have a few exam questions coming up as well. Just one more thing to look at as well is we can use this formula to investigate or to prove whether points are collinear. And collinear means that they lie on a straight line. Okay, so that you can see the word linear in it. So co together, linear kind of line. So it's whether the points kind of just lie on a straight line, because if they do, if we have points like this and we try and do that area of the triangle, then the area will be 0, because if I try and draw a triangle here, I don't have one. I would have a triangle of area 0. So to use my formula, again, same thing as we've had before, we have to translate one of the points to 0, 0, which means doing -2 here and -4 here. I'll apply the same thing to B as well. And sometimes what you'll see is people for the translated points will use this A dash, and that's something we will come across later as well, but sometimes that can be helpful to kind of distinguish the points themselves. So applying the same idea here and getting kind of B dash, I suppose, 2, 2, and the same thing with C then, 6, 8. And again, applying the same translation. So -2 gives me 4, -4 gives me 4 as well. Then using my formula, a half times x1, y2, so we'll do 2 times 4 minus x2, y1, 4 times 2. We can kind of see where this is going. 8 minus 8, which is a half, times 0, which is 0. And then we'll just make a little note. Therefore, A, B, C are collinear. Make a little note just to say that they are collinear. So again, that's just good practice, just to lay out that we've answered the question. So let's look at, we have 2 exam questions here using these kind of formula. So the first one says, find the area of the triangle with vertices 1, 1, 8 minus 5, and 5 minus 2. So same idea applies really. So we'll take the point 1, 1, and we'll maybe move that one to the origin, which means doing -1, -1. We'll apply that same thing then to the other points. So taking away 1 from both of them, that gives me 7 minus 6. And then 5 minus 2 will become 4 minus 3. Then I'm just using my formula. So let's get back into writing this out, just for our exam question ones. So we do 7 minus 3 minus 4 minus 6. So minus 21 and plus 24. So half times 3, which gives me 3 over 2 as my answer. 3 over 2. Okay, and we'll say 3 over 2 units squared. Okie doke. So continuing on then. Continuing on, next exam question. The line cuts the x-axis of P and the y-axis is Q, and we're asked to write down the coordinates of P and Q in terms of K. So this is coming back to the things we looked at in that fundamental formula. So where it cuts the x-axis is going to be where y is equal to 0. So let's write that down. So P is going to be x0, Q is going to be 0, the y-axis. So it cuts the y-axis when x is equal to 0. So let's have a look at that then. So using my line, so if I sub P into my equation of my line, I don't know what the x value is going to be. I know that the y value is going to be 0. I don't know what k is, and I'm just kind of rearranging as best I can. So x is minus k over 4. Same thing happens with q then if we just go the other way. So let x be 0. Don't know what the y value is going to be, and again solving for y, I get that y is equal to k over 5. Okay, so P then is minus k over 4, 0, and Q is k is 0, k over 5. Then the next part, the area of the triangle OPQ is 10 square units where O is the origin. Find the 2 possible values of K. And the hint says use a different formula for area of a triangle. Okay, so let's have a think about that one. So why can we not use our actual formula? Well, you can kind of see here, if you think about our normal formula, so we would do x1, y2, which would work out fine. So let's try and yeah, let's just stick with our normal formula. Okay, let's just stick with our normal formula and see how we go. Okay, we'll judge it that way. So my area formula is a half by x1 y2 minus x2 y1. Okay, let's continue with this. So minus x minus k over 4 by y2, which is k over 5, minus 0 by 0. So we get minus k squared over 20. That's k squared minus k squared over 20. And that's going to be equal to, where we're told that the value is 10. The origin, the area of it is 10 altogether. So again, setting this up a bit more, then minus k squared over 20 is equal to, or the absolute value of it is equal to 20 then. So we had our two methods, so we're going to go with that first method for this one because it just works out a bit nicer for us. So minus k squared over 20 is either equal to 20 or minus k squared over 20 might be equal to minus 20. Minus k squared is equal to 400. So that's 20 by 20. So again, lining this up a bit more. So k squared plus 400 is equal to 0. And over here, we'll have the same idea. Minus k squared is equal to minus 400. So we get k squared minus 400 is equal to 0, which means that k, so the difference of two squares with k minus 20 and k plus 20. So k is either equal to 20, or k is either, or k could be minus 20. Okay. The issue, I suppose, that we run into in the first instance would be that this left-hand side one here. So it's not a difference of two squares. If we were to try maybe and do it as a quadratic, so minus b, so b would be 0, plus or minus the square root of b squared, 0 squared, minus 4 by 1 by 400. And immediately then we're running into a situation where we're going to end up with minus square root of minus 1600 on the top of my fraction there, and that's not actually something that I can work with in this instance because I can use my complex numbers, but we can't use that in this instance because our area is obviously going to be real. Okay, our area can't be imaginary. We can't have imaginary numbers as part of the area or the coordinates of the area of a triangle. We're working in our real coordinate plane. So k is either going to be 20 or k could be minus 20. Okay, those are our two possible options. Okay, let's have a quick think then about why they've said to use a different formula for the area of the triangle. So let's just draw a quick sketch for ourselves. So drawing our little sketch, P was right across the x-axis, Q was right across the y-axis. So this was my point minus k over 4 is 0. This was 0, k over 5. If I kind of sketch out my triangle here, we're looking for the area of this whole yellow segment. Okay, this whole yellow triangle here. So if we were to use our other formula for area of a triangle, which was half base by height, and that's the formula you would have used, I suppose generally with finding the area of any kind of triangular shape, we can say that distance is going to be k over 5 because it's the distance from the bottom of the y-axis up to that point along the y-axis. It's kind of how far up we've gone along the y-axis. If we think about the point P now, even though that x-coordinate is minus k over 4, the distance that we've gone is going to just be a distance of k over 4. So we can say that this is a distance of k over 4. Whatever k is, we don't actually know, but it's a distance of k over 4 anyway. So applying that to my question then, k over 5 by k over 4, and that is equal to 10 because we know the answer is 10. So I get k squared over 20 is going to be equal to 20. So k squared is 400, and we're just ending up at the same point that we had already. K minus 20, k plus 20 0, so k is equal to 20, or k is equal to minus 20. Okay, and those are really our two options, I suppose. So it's really just coming down to there that our base has to be a nice number for us to work with. So we wouldn't, even though that coordinate is a negative coordinate, the minus k over 4, we'd say the distance there is a distance of k over 4. And the same thing would go if it had been minus 3. We would still say that the distance there would be 3. So I suppose with area of triangle, the key things really are kind of knowing that formula, being happy with that formula, and making sure that you're comfortable with this point here, this translation. That's really the key thing that all the questions come down to, is making sure that you can translate your points and then apply them to the questions and use it then in answering those questions and subbing it to your formula and so on.